Hi everybody, Elijah Williams with Fire Creek Forge. Today is an exciting video because I'm going to be showing you the forging press that I just recently finished in the last couple of days. This has been a dream come true. I was fairly recently blessed to be able to win Forged in Fire. With some of the funds from that win, I was able to build this forging press. So I'm going to show it to you today. There's a lot of different videos and information on how to build a forging press online today. So if you're in the market for one, a self-built one, there's probably no better time than now to do that. But where you can start with some different plans, or you can draw up your own plans if you have the knowledge and the how-to. But what I'm going to do in this video today is kind of share with you some specific, not pitfalls, but little roadblocks or things that I had to figure out along the way, and hopefully help you increase your knowledge as to how you can go about doing this kind of thing. And so this is the first one that I've built, and going into this project I didn't know a whole lot about some of the aspects of it. I have a fairly well-versed, I guess, dabbling in different things like welding and things like that, but there's a few things that I had no idea about that I learned, and so I want to share those with you today. So let's take a closer look at the press real quick, and then I'll get into the specifics. To give you an idea of the basic construction of the forging press I built, it's an H-frame style forging press, and the main frame is constructed of 3/8 inch thick 3-inch by 5-inch angle iron. The main cross pieces, or the top and bottom, and the moving carriage are constructed of 1-inch by 10-inch steel plate with an additional 1-inch plates on either side of that in the entire assembly. The cylinder is a 5-inch diameter, 16-inch long cylinder. The assembly that powers this press is a 22 gallon per minute hydraulic pump, 2-stage pump, run by a 5 horsepower motor at 1725 RPMs. Since the pump is rated at 3600 RPMs, it's in practice an 11 gallon per minute pump on the low pressure, high speed end. And of course you have your hydraulic tank, which supplies the necessary oil for the whole system, delivery hoses, pressure gauge, and the control valve, which, by the way, also regulates the pressure of your entire hydraulic system. So a quick overview of how I went about building this. I did buy the book by James Batson, Dr. James Batson, on building a hydraulic forging press, and that is definitely a good resource. I will say that nowadays there's a lot of different information, pictures, some plans online that are also a good resource as well. So don't overlook that either. It's helpful to have a knowledge of hydraulic system, which I did not, and that is one of the things that the book by Dr. Batson covers. So that was helpful. It has some sort of rough blueprints for the press. You do have to kind of sit down and design what you're trying to build specifically, so it is a good aid in designing and building one, but it is not just a completely transferable blueprint. The first thing that I ran into when building this was these 1-inch thick by 10-inch plates. This is hot rolled steel, and as part of the milling process, the steel is hot rolled, so it's cooling off as it's coming out of the mill. And what can happen is a little bit of deformation. So on this particular steel plate, there's this steel plate, the one that the carriage runs on, which I'll show you in a minute closer, and the one at the bottom. And that's where all the high pressure points are when the cylinder is under load. And anyway, it's slightly cupped to the tune of about 20 thousandths in the middle, so it's sort of dished if you lay it on its side. And that's not a lot, but it was a little bit more than I wanted to try to work with when it comes to building this machine. So what I ended up doing, and I'll just bring you closer here on the camera. So this is kind of a side view of the carriage. This is 10-inch plate here that slides in between the uprights, and that's the main body of the moving part of the press. And because these plates were cupped slightly, using a straight edge in a grinder, I flattened the side of this plate that was cupped so that it was within 5 to 10 thousandths the same thickness all the way, instead of thinner in the middle and then having a flare where it cupped at each end. However, I did not do that on the two pieces that the uprights are welded to. I sort of discovered the cup after I'd already partially welded the uprights and tried to figure everything in line. So that's a little bit of an issue, because this moving piece here is about 20 thousandths thinner than the two pieces that are holding the distance, or the width of the uprights. Ways to fix that in the future. The press works just fine as it is, and I do know that you're going to want to have some clearance, if only for the reason of debris and scale coming off. You don't want to have a super tight machine. But down right here, I do have about 20 thousandths of play, and that's bugging the crap out of me. I don't know how important that really is. Like I said, the machine works just fine. But ways to fix that in the future would be to simply remove this, which is possible by taking these two bolts out and just building up one or both sides of this with the welding beads, and then grinding it or milling it down to the appropriate thickness. So that can be addressed. I don't know that it's really necessary at this point. But that is one thing to be aware of using materials. They're not always going to be exact to dimension or true, and so you have to be aware of that. So as much as I would have liked to have a milling machine in the building of this press, I didn't. And is it really necessary? No. I think perhaps I'm a little picky because I did spend some time as a machinist, working as a machinist years ago, and so sort of what I have in my head as far as tolerances go are probably a little tighter than you actually need for something like this. But that's just me. So moving on to the next thing that I sort of learned or discovered, and that is, whenever you're going off of a suggested plans or even your own plans, when you change a dimension on something, make sure you double check that everything that's affected by that dimension is also changed, or that doesn't need to be changed. And so in this particular instance, I was sort of going off of the suggested plans in the Batson book, which was for an 8-inch long cylinder. I decided to go with a 16-inch long cylinder, and I forgot to change the length of my uprights. And so in the original design, these uprights should go all the way within half an inch of the top of this plate and all the way down to the bottom on the bottom of the press. They don't. So I ended up doing a lot more welding, filling this in to ensure there's strength, and then augmenting the bottom with some square tubing. So the strength of the machine is completely fine, but it would have been quicker and cleaner had I paid attention to all the dimensions and purchased uprights that were the appropriate length. Something else that is not quite as perfect as I would have liked is these guides for the carriage. They are welded on this side only, and if you're familiar with welding at all, you know that welding beads contract as they cool. And so welding it on this side, even though it was originally squared up and true and flat against this with a little bit of clearance, the steel tends to torque as the weld contracts, so that these are not anymore completely flat against this this upright, and that bugs me a little bit too. How much does it affect the use of the machine? Not a lot. Is it fixable? Yes. I would have to pull this whole carriage off, as I mentioned earlier, and add some steel, some metal with a welding bead probably, and then preferably mill it on a milling machine. Don't have that capability right at the moment. In the meantime, the press is working just fine. The reason I have a 20-gallon tank is because I was looking at a 15-gallon tank, which is also probably a little larger than needed. But the 20-gallon tank was the same price from where I was buying it, and it had some feature I don't remember now that I thought was necessary. It came with a breather cap, filtered breather cap, so that was nice. So I ended up with a 20-gallon tank. I've heard a couple different rules of thumb on the hydraulic systems and how much oil you need to have for the system. One rule of thumb is that you have a tank that has the capacity of the minimum amount of your gallons per minute on the pump. So on this particular pump, the highest GPM it has is 11 gallons per minute at the RPMs that I'm running it at. So an 11-gallon or even a 10-gallon tank would probably be sufficient. If I remember correctly, however, you're not supposed to fill the tanks all the way up. So that's what put me to a 15-gallon tank that I was originally going to get, and then, like I say, shopping same price for the 20, and had a feature that I thought was needed. So 20-gallon tank has about 15 gallons of oil in it, and that is more than adequate. The other rule of thumb I've heard is a tank capacity with half of your highest GPM. I think it really boils down to how much you're going to be running it. At the end of the day, what it boils down to is I'm never going to have to worry about my hydraulic oil overheating, and that's a good thing. One of the challenges with this build was figuring out the hydraulic system. The Batson book was very helpful in that regard. The materials list in the Batson book is also very helpful in that regard as well. There were a couple of things that I missed, or that didn't quite line up with my particular build. One of the hardest things though was figuring out kind of where my intake and return hoses and all of that kind of thing were going to go, and how to orient the tank. It took some figuring and where I was going to run hoses and stuff like that. So being able to sit down and figure that out, I just didn't quite have it in my head when I sort of drew the plans up for this. That would have sort of allowed me to have a little cleaner hose setup here without some of the excess that I have now, but I wasn't able to sort of put that together in my case. More specific blueprints and plans would have probably helped that. As far as hydraulics goes, I did learn some practical things about that, and I will say that in any spot where you cannot use a pipe fitting for the hydraulic system, don't. There are, in the Batson book, for example, there are suggested fittings which are pipe threads on both sides, such as hooking up to the hydraulic hoses down to the cylinder, also up at the valve and that kind of thing. What I found on my build is that even with the pipe dope, the Teflon paste, you don't want to use the tape, I've been told. It can flake off and get into your system and valves and that kind of thing. So using the Teflon paste is necessary to get a good seal, but even with that, I was not able to get a good seal on the different places where the hydraulic hoses were connecting to a pipe thread. Now, if you're familiar with pipe thread is threaded just like a nut, however it's tapered, and so it's very common. It's what's used in household plumbing and that kind of thing. You can get high pressure, not household plumbing, but high pressure pipe thread fittings for this type of application, but even then the pipe thread is the same, and it requires sort of a tightening effect to actually make a seal, and it just doesn't work very well. What I found after chasing multiple leaks is that the actual hydraulic fitting swivel type connector is working great, because if you look at a hydraulic hose, I don't have one off to show you, but it's very similar to your propane type fittings, which if you've seen those, they have sort of a indentation on the inside of the male hose, and when it connects up to the female side, that has sort of a cone that fits into there, and that's what actually makes the seal on those fittings, and not the threads, not the pipe threads themselves. And so I found that to be rather important with this high pressure system. The places where it is only a pipe thread fitting, such as where you feed into the cylinder and into the body of the valve, those seem to be holding just fine, and I don't know if it has to do with the type of metal that those pieces are made out of, a little bit softer, allowing a little bit more very slight deformation for a seal. I'm not sure. But what I have ended up doing after finally getting everything to seal is using, for the most part, the swivel fittings where they connect to the hydraulic hoses, where they actually have that cone that it seats into and makes that seal. The only ones I haven't had to switch out are the ones that are in the cylinder, and thank God they're actually holding with just the pipe threads onto the hydraulic hoses, so happy about that. Hopefully those hold for as long as need be. Next, I want to talk a little bit about the pump and the pressurizing system, the hydraulic system itself, because I didn't really understand exactly how it worked when I first started doing this. This is a two-stage hydraulic pump. It's actually built for a log splitter, but it's perfect application for this as well. And like I say, it was rated to run at 3,600 RPM, 22 gallons per minute. A lot of guys get a higher gallon per minute pump and then run it with a motor that puts it at half the RPMs, and that runs it quieter and just, I guess, sort of helps with the life of the pump anyway. So that's what I chose to do. And of course you have your spider type coupler over here. It's got basically a rubber shock absorber between these different teeth, and it sort of helps keep things a little quieter and just reduces the wear and tear on your machine. These are basically simple mounts. You have to have everything lined up as close as possible and bolted there, and so it's good to go. But talking about the hydraulic system, the pump runs at the first stage, the high-speed stage, until it reaches a certain pressure point, and I believe that's 500 psi. At that point, the pump kicks over to the slow-speed, high-pressure stage, and it'll pump up to 3,500 psi, but only at 2 to 3 gallons per minute. I don't remember what this pump is exactly, but the average is 2 to 3 gallons per minute at that low-speed, high-pressure stage. Now, you cannot run your system at any pressure you want, obviously. These hoses are rated for 3,500 psi, and that would be too high for a system. Most systems are 2,500 psi to 3,000 psi, but what I didn't understand going into this is how you actually regulate that and how that actually works. So let's hop up here to the control valve, and here you have your high pressure oil coming in to the control valve, and under normal circumstances, when your motor is running, it simply passes through this whole control valve into the return line through the filter and down back into your tank, and it just sits there and cycles through there and nothing happens until you move this valve one way or the other, and then it sends the oil to either one of these two valves and either pushes the cylinder up or down. And then, depending on the resistance that you place with the cylinder, depending on the work you're doing, that's what determines the pressure of the system. Now, if it weren't for a nifty little feature on this valve, the pressure of this system could just continue to rise until something blew up, which would obviously be very bad. The way that you keep that from happening is on the control valve, under this nut that you take off, there is sort of like a giant set screw that you can adjust up and down, and that is what regulates the pressure of your entire system. The way it does that is determining at what pressure it begins to allow the oil to bypass and not continue to build pressure. And the way you determine what that pressure is with your pressure gauge, which is situated between the pump and the control valve, because what's pressurized is between the pump and the load on your cylinder, which is that whole system is what's pressurized. So that's where you place it, and you can adjust your control valve accordingly. And then from that point on, whenever it gets up to this particular PSI, it begins to let the oil pass back through, the appropriate amount of oil pass back through the return system, and it maintains that pressure, won't go any higher. Something else I want to show you is this filter housing, the original filter housing I had on this, and it had a bypass feature in which if the filter was plugged up there at a certain pressure, the oil could bypass through a spring-loaded device in there and continue on, so you wouldn't continue to build pressure. However, that little feature broke out, and you can't really see in here, but it was just held in there basically with some rather thin veins in the center of that, and there's a rod and some valves. It broke, and it lodged into the return hose of my hydraulic system, and it blew my filter up because of that. I don't know how this broke. I don't know if the part just failed, or perhaps I got a little bit of a water hammer action going, a little too excited on the valve up and down. I don't know, but that happened and blew my filter up, sprayed a little bit of oil on the wall, and I wasn't aware of what had actually happened. So I went and got a new filter and put that on when I still had this original housing, and I noticed when I turned the pump back on, this filter was bulging a little bit, it returned back to its original size. But then I was looking at my pressure gauge and I had about 500 psi on the system without even touching the valve, which is obviously not what it's supposed to be. So I pulled this apart, found the little pieces lodged in the return hose, and got those out. Went down and got a new solid cast steel this time, filter housing without that bypass function, because quite frankly I don't think that's necessary. Put it all back together and everything was good to go. But when you're buying your filter housing for the system, personally I would stay away from these cast aluminum bypass feature, which I did not know it had. If I'd have known that, I would have not probably got it. So this is just a solid basic, runs it through the filter and back out, no nonsense type deal, and that's been working great ever since. Okay guys, so that's the press and some things that I learned in a nutshell, and I've already been able to forge some Damascus on it, finished one knife so far off of that, so really excited about having this in the shop. So thanks for watching. If you have any questions, shoot me a comment. Or how do you do that? I don't know, on the FaceTube thing, whatever. I am on Facebook too, so you know, Elijah Williams Knives, check it out. But thanks for watching. Have a great day, and stay tuned for some more good content. Thanks. Remember what I was saying about swivel fittings? Yeah. Yep, looks like the last two are gonna get switched out. That's literally like the last two. I fired up to show you guys. Yep, spring a leak. And yes, I know I need to put that in a conduit. I know. Anyway, yeah, looks like I'm gonna run down to the old parts store and get another couple swivel fittings, and hopefully that will be the last time. Just get swivel fittings that, you know, skip the pipe thread. Okay.